This video covers Vrap Section C. In this video we're looking at rates. Now a rate is a comparison of two quantities with different units. So you can see with ratios they had to be the same units. Rates compare with different units. Now a rate is usually expressed as a fraction in lowest terms and units must be included. So let's look at the first one here. Ernie used 1.5 kilograms of fertilizer on his lawn. Ernie's lawn measures 100 square meters. So expressing this rate as a fraction, we would go 1.5 kilograms over 100 square meters. From there we can't have the decimal, so we times top and bottom by 10 and we get 15 kilograms is to 1,000 meters squared. We can then simplify by dividing the top and bottom by 5. And you get 15 divided by 5 is 3 kilograms. 1,000 divided by 5 gives you 200 meters squared, which you express as 3 over 20 kilograms per meters squared. Okay, next, travel 350 kilometers on 45.5 litres of petrol. Whether you put the kilometers or the litres at the bottom really depends here, because the difference between fuel efficiency and fuel consumption, but we'll just do it in this case as our kilometers on the top because it was the first one given to us. So 350 kilometers over 45.5 litres. Again, we need to make that bottom number a whole number, so we're going to times top and bottom by 10 and get 3,500 kilometers over 455 litres. From there we need to reduce it and we will get 700 over 91 kilometers per litre. So our units is just the first per L, which is really the fraction there. Now expressing rates like that really doesn't make much sense. So what we can use is a unit rate. Now a unit rate is a rate that has been simplified by writing the fraction with a denominator equal to 1. So basically what you're doing with the previous questions is just dividing the numerator by the denominator. And again, remember that units must be included. So let's look at these examples. Same questions with or similar kind of questions, but now we're going to divide. So write each of the following as unit rates. Earn $231 for 22 hours of work. So my rate is going to be $231 over 22 hours. So from there, just divide 231 by 22 on your calculator and you get $10.50 per hour. Next, travel 350 kilometers on 45.5 litres of petrol, exactly the same as what we did previously. But in this case, we're going to go 350 kilometers divided by 45.5 litres. And we're going to work that on the calculator. So 350 divided by 45.5. So you don't have to worry about making it a whole number. And we get approximately 7.692 kilometers per litre, which you might just write to 2 decimal places. Okay, next, exchange $35 US for 61.90 Australian. So from there we're actually doing an exchange rate here, and that's going to be US dollars 35 over 61.9 per Australian dollar. Okay, work that out in your calculator, you get approximately US 0.565 per Australian dollar. I know Australian dollars are usually AUD. If you went the opposite way, if you went, you could also write it as 56.5 US cents per Australian dollar. So you could write it that way as well. Either's fine. Now normally we will do unit rates in rates rather than leaving it as a fraction. So if it's not specified, always go for the unit rate. Now by writing rates as unit rates, rates can be compared. Okay, so firstly you have soft drink is advertised at $11.99 for 30 by 375ml cans, or $8.99 for 24 by 375ml. Which one's a better deal? So to work out the better deal, if we look at the first one, we need to know what our cost per can is so we can compare. So our cost per can is going to be $11.99 over the 30 cans. Put that on your calculator, you get approximately 0.3996, actually, it's exactly, because that's recurring, per can. Okay, now look at deal 2, cost per can. In this case it's going to be $8.99 divided by 24 cans. Plug that on your calculator, you get approximately 0.375 per can. I can compare these two numbers and conclude that it costs less per can for deal 2. So therefore deal 2, 24 cans for $8.99 is cheaper. Okay. How about stopping and trying to do this one yourself, and then pausing, coming back to it after you've tried it. Okay, Edward drove his car for 252 kilometres and used 27 litres of petrol, while Ella's car used 33 litres to travel 415 kilometres. Whose car is more economical? Now, as I just said previously, this question, the rate could actually go either way. Are we looking at fuel economy or are we looking at fuel consumption? So I'll do it both ways. I'll firstly look at fuel economy, and then I'll look at fuel consumption to show you it doesn't matter which way you go. Now for fuel economy, if we have Edward, it's going to equal 252 kilometres over 27 litres, which equals 9.3 recurring kilometres per litre. Now for Ella, we're going to have 415 kilometres over 33 litres, which gives me 12.57 kilometres per litre. So you can see here for fuel economy, we're looking at how many kilometres you can travel per litre. And from here you can see that with this, Ella's car goes more kilometres per litre. So you're saying Ella's car is more economical because it travels further. Per litre. Okay, when you're looking at fuel consumption, you go the opposite way. So Edward, you're going to do that 27 litres over 252 kilometres, and you'll get approximately 0.107 litres per kilometre. Okay, for Ella, you're going to have 33 litres over 415 kilometres, which will give you approximately 0.0795 litres per kilometre, to see how many decimal places to go. Again, what you're saying is that Ella's using less petrol per kilometre. Okay, so therefore Ella's car is more economical because it uses less petrol per kilometre. Okay. So let's do some practice. Vrap C1 and Vrap C2 of the textbook.